Let's do another example in our fifth exercise. It says that draw the horizontal line that includes A and B points on the apple of Monge. Again, we can use another A4 graph paper and create our three squares over it. And in order to remember the horizontal line, let's look at this slide one more time. Horizontal line is this one. It is the one that has been positioned parallel to the horizontal projection plane, and it is inclined to the other planes. So we can easily say that when I am looking at the system from the above, I realize that I am seeing the projection of this line here, and it is the same with the actual line. Everything is the same. They are equal. But when I'm looking from front or from the side, then I realize that the projection is not equal to the exact line, the same line. They are different. It's been projected smaller than the actual line. So this is what we are going to draw here. Again, we are going to start with indicating the positions of the points. And this time we see that this line here has two traces. One, which we symbolize with lowercase v, because it is the intersection of this line with vertical projection plane. And the other one is symbolized with lowercase p, because it is the intersection of this line with projection of profile projection plane. And we see two angles here. They are the inclination angles of this line, which is being created between the line and the projection planes here, V and P. Yeah, this is what we are going to do. So let's start by drawing the first step. When we look from the above, we see that point A is being projected as A prime on horizontal projection plane. In order to locate the position of A prime, we need two lengths. These are interval for A, it's 2 squares, and distance for A, it's 4 squares. Again, we are going to do the same for point B. When we look from the above, we see that point B is projected as B interval on horizontal projection plane. And in order to locate it on our drawing on Epure of Monge, we need two lengths. It is 4 interval for point B and 1 distance for point B. So when we locate these 2 points, A in prime, B prime, the important thing is to combine these with an actual line, and we get this line segment. And we can easily say that AB is equal to A prime, B prime. They are exactly the same, the size, everything is the same. Let's just look from the above, try to see the horizontal projection plane right in front of us. Let's not concentrate to the rest of the drawing. And we see vertical projection plane as a line, profile projection plane as another line perpendicular to each other. And by using interval and distance 2 and 4, we just need to count 2 for here on this direction and count 4 towards this direction, and their intersection indicates the A prime here. I just need to show it like this with this cross and write its name. And by using 4 and 1, this is the interval and distance for point B, I just need to count 4 squares and 1 square here, and its intersection indicates the B prime here. And then I just need to combine these two lines like this. And if I just keep going here and here, I will realize that this intersection indicates the trace, one of the traces of this line. I can easily say that since this green line represents the vertical projection plane, it means that this line is intersecting with the vertical projection plane. And I know that its trace is being called lowercase v, so I can easily say that this is v prime right here. And similarly, if I keep going like this, I can easily say that because this red line represents the profile projection plane, it means that this line and profile projection plane is intersecting at this point. And this is the projection of its second trace, which I call p, lowercase p, but it's not the actual point of it. It's the projection. So I need to name this as p, lowercase p prime. And I have two angles here. First one is this one. Second one is this one. So I can say that these are the exact same projection of inclination angles of this line. Here, one angle is being created between the line and the projection plane as, let's say, let's name it as beta, beta, and its projection we can call beta prime. And here we have another angle which is being created between the line and the plane. Let's call it alpha. The name of the angle is alpha, but we see its projection here, so we can write alpha prime for this. Let's change our position for the second step. Now we are looking from the front direction, and we are seeing vertical projection plane right in front of us, but we cannot see horizontal and profile projection planes, and we see them as lines. So I need to locate the positions of A double prime, B double prime. In order to do that, I need two lengths, the distance, but I don't need to count one more time. I can just carry this length here using this part of my drawing, and do the same for B. Again, I don't need to count the distance. I just can transport this information from here to here. And in order to indicate their exact location, find their exact spot, I need to have their levels. It is the same for 2 points. It's 3 squares. I just need to count 3 squares and carry this information here. So here is my line segment. I can indicate this as A double prime, this one here, B double prime. And when I'm looking at the system, at this direction, I see both the trace itself, lowercase v, and its projection right on it. They are overlapping, so I can write v double prime here. And this is the point where the line is intersecting with the plane and going to the other side of the plane. But I cannot see the P, actual point P here. I am just seeing its projection on the vertical projection plane. So this point indicates the P double prime here. I am going to clear the drawing now. Yeah. And here, I cannot say that AB E is equal to A double B double prime B double prime. It is smaller. than its actual length because of its position. And I can just indicate it like this. This is the hole the line makes. And after passing through this hole, the line I cannot see the line anymore because it is behind the vertical projection plane here. And for the last step, I need to change my position. I am looking from the left side of the system, and right in front of me, I am seeing the projection profile projection plane, but I cannot see the vertical and horizontal projection planes. I am seeing them as two lines here. So in order to determine the location of A triple prime, B triple prime, I need two information. The level, which I can carry from here, which I can transport from here, this part of the drawing, and intervals for both points 2 and 4. And I can just transport it from here. So these intersections, this one here and this one here, they are indicating the projection of my points, A triple prime, B triple prime, and yeah, since I am transferring, and here, this point here, the last thing that I have transported, it is the second trace, the P of this line, which overlaps with its third projection, P triple prime. I am seeing the trace itself and its third projection, but I cannot see its first trace V on the system because I cannot see the actual projection plane V here. So I am just seeing its third projection. This is what I am supposed to write. This point here represents V triple prime. And that's all. Again, I cannot say that the actual length of this line is not equal to A double prime, B double prime, or A triple prime, B triple prime. They are not the same. Because of the position, the actual line seems smaller. And this is the last thing that I will do. Let's call this line here as T. This is line T. And on this drawing here, I am looking at T prime. This is T double prime. And this is T triple prime.